So in the architecture, we have definition, object, and collection. Definition will store the metadata about on which database table it is dependent and what types of columns it has. And at the runtime, when we query data or create new rows, each row is created as an entity object which contains data for that particular row, and then a collection which contains these rows. So when we need to extend the functionality of entity object, what we can do is we can extend these particular objects in the architecture, which are actually classes. Okay, so how do we extend that? If suppose we don't extend, what happens is in the background they are backed by framework classes. So entity def IMPL, here the first one. So entity def IMPL is the backing class, which is inbuilt framework class, which will represent the entity definition as a Java class. So ADF has an internal implementation of that. We don't look into that. But suppose if we want to extend the definition object and customize it, we will extend this class and write our own code in the extended class. Similarly, for the object definition also, there's a base class called entity IMPL. We will extend this class to write our own logic. What kind of own logic do we write? For example, on the UI, user has entered a salary. It's with the default implementation, it simply goes to the entity objects attribute, and then it sets in the cache, and when committed, it goes into the database. But I want to do some operations when user sets that salary. When he sets that salary, suppose I want to do some other checks and see whether the salary is valid or not, or I want to give some bonus on top of that. So all these operations are custom business requirements. That things we can implement when we extend these framework classes. Okay, so the backing classes for each of these objects we are talking about in the architecture are this particular class. You don't need to memorize these things. This will be anyway visible to you in JDEV also, and you don't even write code for extending that. It's declaratively done. Let's see how we do that. Okay, in JDEV, I have opened the entity objects EO, and in that I have a Java section. Okay, here I can extend my classes. There's a pencil icon on the right side top, which means edit everywhere in JDEV. Whenever you see pencil icon, there is an edit option. Okay, click on that, and you get to see this window where it lets you extend the three types of classes we were seeing. This is the definition class at the bottom, which is on the top. Then the object class, which is at row level, and the collection class. Generally, we don't need to override these two classes. That is the collection and definition, because the default implementations are most of the time enough for us. Only in very, very advanced cases, we need to override these things. Otherwise, we normally don't do. So let's not bother about these classes. But entity object class, which is at row level, is what is frequently subclassed to extend the code. Now let's see, when I say generate entity object class, it is giving me by default a name for this based on the entity name, employees EO, followed by IMPL. Okay, so it gives a default name. I'll leave it there. And by the way, I said you don't need to memorize the classes, right? You can see the classes here. In the classes extent, you can see the base classes. What was the base class for collection? What was the base class for row? And what was the base for definition? So we currently are extending this base class, which is a default implementation provided by the framework. And we are extending that. I say OK, and I get my class here. Also, here if you expand the employees EO in your application navigator, you will see the Java class created here. Okay, along with your XML, which we have been seeing till now, we have a Java class. Let's open this. Click on this link. It created an extended class with some inbuilt data. Let's see what this is. First thing, It has a package name. By default, the same package where the EO exists. And there are some import statements which are dynamically coming up when we use those classes. Here, this is our class name. Employees EOMPL is our class name which we are creating now. This extends the inbuilt framework class which is called entity IMPL. We'll have it in the import. So this is the class. Okay, we are extending this particular class, and we have methods inside this class which we can override. Okay. Also, it will have an enumeration here. This is attributes enum, which will contain all the list of attributes it has. This we will not anyway modify. This is automatically generated for us to use in our code. Internally, it represents all the attributes as an array list. Okay, so it names each attribute like this. In the enumeration, it has all these attributes. Okay, employee ID, first name, last name, everything. So this we will be using when we have to manipulate this particular fields. Okay, and then we have the default constructor, empty constructor, and two default methods which are create primary key and a static method to get like these two are static methods to get a definition of it. Let's see how in the programming section we'll see how this will get used. As of now, just understand that we can create a class like this. Okay, so just explain the structure. We'll add more things to this class. Go to edit, and here we have four options: accessors, DML methods, create method, and remove method. Now, suppose if you want to override these methods, suppose there is a create method which by default creates an empty row, but in create flow you want to do some logic. So suppose setting a default value, you could have done it declaratively there. As we saw, we put a default value for salary. Alternatively, you can put it here also. So whenever create method is executed, we can do such manipulations here. As soon as my entity row is created, I need a control to do my own logic. Okay. So these methods are actually called callback methods, which are invoked by the framework. Once it completes doing its own work, it gives handle to us, so that we can also extend the same thing. Let's see one method first. Let's see the create method. I selected the create method. I'm asking it to create this template of this method. I say okay, we go here. Now I have my create method. There's no code in that. It's actually calling it superclass method. Okay. What this means is I have a control. I have a handle here. I can add my code whenever a create operation happens on my entity object. Okay. So I'll call the super, and I can do a set attribute here. I can write like my set salary to something. Okay, something I can do like this. I can add my business logic code here. So that's the purpose of extending framework Java classes. Similarly, we have a remove method, and okay, remove is a simple method which will do just remove. Then we have data manipulation methods. I'm selecting them. Let's see what they are. So this session is not about programming, so I'm just showing you the methods, not what to write inside that. How the methods get created. So there is a remove method here, and there is a lock method here. There is a do DML methods here. Shortly in lifecycle, we'll see what this do DML is. Anyway, the point is at different timings in the lifecycle of entity, you can have handles to override the behaviors. Okay, when the row is deleted, this method gets executed. At that time, what I want to do, I may want to do some cleanup logic or something. I can add it here, like that. And the other important thing is the accessors. Accessors means for each of the attribute that you are seeing in the definition, you can have a setter and getter. Yeah. Why do you need this setter and getter? There are multiple uses for setters and getters. That's a design pattern actually. To manipulate attributes of any class, it's advisable to use the setters and getters. For one reason is that when you use a set attribute, and set attribute means you'll set a value for an attribute, and the get attribute is to get value from an attribute. But there you need to specify the field name explicitly. You have to type in the field name. So typing can cause human errors is one thing. Also, when you do typing, you say get attribute, you will get an object type of item. You don't know the data type of it. So it's a generic method which will return an object value. So to avoid that type conversions and any typos, we'll use this getters and setters. These are called getters and setters, which will help us do the coding without any errors. Like if I say just get employee ID, I'll get a compilation error if I simply misspell anything because it's a method. In fact, internally it's doing my get attribute internal only. The same method I could have used directly, but in that case I should have passed the value name of the attribute. Okay, in programmatic session we will see all the details of this, how to use these things. But just for now, understand that you can create all these getters and setters and DML methods, etc., in your entity object. Okay. So that's the Java classes. Suppose if you create these things, then they'll also get created. You can see them of not much use. This is EODEF IMPL and this is collection IMPL. Even if you create empty classes, it's of no harm. They just remain there without doing anything. Okay, that's the classes section. Then we'll move on to validations part. Okay. Validations means to maintain consistency of data, we'll have validations defined on the entity object. So where we can define validations is at the attribute level and the entity level. What difference it makes is on the attribute level means as soon as you set a value or an attribute, the validator gets executed. It means as soon as you put a value in an attribute and move focus to next attribute, immediately the attribute gets validated. That is, it has enough information to validate there. But entity level validation means after entering all the attributes, you move to next entity. At that time, it gets fired. So why we need to get a handle at that point is, suppose your validation depends on some other attribute also. Both attributes need to be set for the third attribute to be validated. In such cases, you'll move your validation to entity level. So let's see how we do that in JDEV. Let's go to attributes. And we have validation rules here. Let's say we'll take hire date and go to validation rules. Already we have one rule defined here, that which came from database constraints, which says hire date is mandatory. If you go and edit and see, okay, this is a mandatory type of validation which is coming from DB. Because we created this entity object based on database table, this hire date was a not null column there. Because it was not, let me show that also. I'll go to databases. Let's see its structure in database. ESC, I'm describing employees table. When I describe this, you can see that hire date is a not null column. So database itself has the constraint. So automatically our entity object will have that constraint. Why it has that is, whenever it created entity object based on database, it will copy all the indexes, validations, everything into the model, so that they can do the validation early, even before going to the database. Suppose if we didn't have this validation here, and we let the control pass through it, then what happens is when you try to commit it into the database complains that it is not null. Then you will not have handle of that exception. That is one point. And unnecessarily you are making a database call to do that validation. You can do that in the middle tier itself when the data is still in the cache. So it will be faster and more consistent. You can warn the user that the wrong data is here as early as possible. So we get the constraints from database to here. We can also define our constraints.
Sir, I didn't understand.
This one, validations part?
Mm-hmm. Yeah.
Okay. So you understood why we need to have a validation?
Yeah.
Okay, but why we had it in the entity object level is what you didn't understand, right?
Yes.
Okay. Now database table had this validation. It's a not null. So if I do any insert into this database, it will complain that it's a not null column. You cannot insert a null value here. The same validation, I'm duplicating it into my entity object. So why I'm duplicating here is, in the application when I use this, suppose there is a UI based on this entity object, and user has not entered a value and he clicked submit. So what happens then is the framework tries to save this data onto the database. For that purpose, it has to make a DB connection. As I said, we will work on the cache till the time we are going to commit it. Creation
Yeah.
of rows, deletion, updation, everything we'll do it in the cache. Let me get back to that slide.
I remember that.
Okay. So all operations will happen in cache only. That is because it's all in the memory. In-memory operation, which will be faster. Okay. If I didn't have the validation in the cache level, that is in my entity level, what would have happened is the wrong data would be tried to commit to database, and database will complain that it is null. The problem there is it's costly affair to access the database. That is one thing. And when database throws an error, again we have to catch it and display it to user. So to like we are going, say for example, there is a UI. Normally on the UI, we are taking a date input, and it's common sense that a month will not have 32 as a date. Suppose if UI is not able to validate that, and it is asking the middle tier to validate the server call, there will be unnecessary server round trip, right, to validate that basic data. So it makes sense to put a JavaScript validation there itself, that date cannot be more than 31 or depending on the month. So a permanent validation which we were aware of could have happened in the client side itself instead of making a server round trip. This is similar. Instead of making a DB round trip, if we know the conditions in advance, we could have prevented that check. I mean, that wrong data from passing through. I mean, it's wasting a lot of time and resources to get validated. So early validation is our key thing. Whenever possible, we have to get the validation as early as possible. You got that? For that
Yeah, I
reason,
got
we are.
it.
Yeah, got it?
Yeah, I got it.
Okay. For that reason, we are moving the validations which are on the DB level to our entity also. Okay. So we have a built-in, I mean, whatever validation was there on the table, we got it here. We'll add one more. I say plus here. And I get my add validation rule wizard here. Here, I'll have a name for that. Name can be anything, just to refer it. I can write a description. And here, we have different types of declarative validations possible. As I said, we are going through all declarative validations. So there is a compare validator. It means when I select that, it gives me options. Compare my hire date with something, a literal value or some query results or some other attribute. So there are some options to do. Okay. So the compare validator will give me a way to define a validation. This is a compare type of validation. So it's checking if my current value is equal to some, suppose I'll say 2015 October 10. So it will compare this validation, I mean my hire date to that date, and if it is equal, I mean the condition is here. If it is equal or less than or greater than whatever I can define here. So I can give a literal value here or an expression here. Expression will be like a Java code. I'll say ADF.current date, which means this is date, the current date. So if hire date is equal to ADF current date, then my validation will pass. Otherwise, it will not pass. Likewise, there are other validators. Length is for checking the length of operator, how much length it should be. If suppose it was a name, I can check for length here. List validation is, I'll give a specific list. For example, I'm taking days of the week. Then I can give a list of Sunday, Monday, Tuesday, etc. here. And I want to ensure that the user input is within that list. And then a range is like a between validation. A regular expression is again, regular expressions are pattern matching concepts where you can check the input string is in this pattern or not, like that. And the other important thing for us is method validation. This is programmatic way of doing it. All others are declarative, only method is programmatic way of doing it. When you say method validation, you have a method created. So now where it will be created? As we saw in the last slide, we created some Java classes to back up this object, right? So there, when we are doing an attribute validation, it goes into the row level class. That is our entity IMPL class. So when I say validate method, a method will be created there, and it has to be having this signature. It should be a Boolean return value, and it will take the input of whatever user has given. So data type will be the current attributes data type, and you have to return a true or false from that method. Okay, let's see one example. We'll go to method, but before that, let's see one example of compare. I want to see hire date is greater than or equal to, I'll give an expression, current date. So I want to ensure that my hire date is greater than current date. That's the validation I want to do. I can do a syntax test. Okay, my expression is fine. So these expressions are called groovy expressions, which are shortcut way of referring Java code. So there are some keywords for that we'll be using, not many. That keywords, if you understand this, that's enough. So ADF current date will return us the current system date. What I'm trying to do is I'm comparing my hire date to be greater than or equal to this date. Suppose if it is not, then what I should do? That is defined in the failure handling condition. Before that, there is a validation execution tab, which will give me conditional validation. For example, only if it is of one, only if the employee is of some particular department, then only check this date. Okay, for example, so I will say job ID equal to IT programmer, then only apply this validation, otherwise not. That's the kind of condition we can put. As of now, we'll apply it for all the situations, no condition. And what to do if it fails? It should show an error or a warning message. Error will completely halt the execution. Warning will just warn the user about some information, go proceed ahead. Let's say it's an error, we don't want to proceed. And say that hire date should be greater than, I'm giving a message which will be displayed to user. Should be greater than today, for suppose, okay? And I say, okay. Now let's test this. To test this validation, we need to use AM tester. In the first session we saw, that's the first point of testing available to us. Okay, we'll test that through AM tester. Let's open up the application module. But before that, I need to ensure that my EO is in the AM. But can EO in the AM? Can EO be in the AM? No, there should be a VO. AM can contain only view objects, not the entity objects. Entity objects are for the purpose of talking to database. View objects are for the purpose of talking to the user interface. Now AM is our broker with the user interface. So it needs to contain the view objects. Okay. So first I need to have a view object on top of entity object, which I already have. See, there's my employees VO. My employees VO is there. It is depending on my entity object. So I move this employee VO into my application module. Let me clear them off first. I'll remove everything. Now my app module is empty. I'll select my employee VO and move it here. So now my AM has one instance of employee. See, it got the number 1. It will keep on naming them as 1, 2, 3, 4, etc. These are individual instances which are created at runtime. Okay. Now I right click this app module and say run. I have a saved file. So it's running and you can see the logs in the bottom. Okay, I got my tester. Now in my tester, I can see this view object, employees one, which is the same one. When I run that, I got my records. So in the last session, what we did was we made first name as not updatable. That's why it's grayed out. Okay, and that's it. I'm creating a new row. Okay, I got a chance to explain this also. The first name is now open. It was because in my employees attributes, the first name I have put updatable to while new. That's the reason I'm seeing it as updatable when I created a new record. So created a new record in memory, not yet committed. Okay, let me try to, I don't need to create a new record. Let me change the existing record. So here, what we were trying to do is hire date. I'll put it as some other date. Suppose, yeah, this is an old date. So I'm changing it. I'm putting it to an old date, but my validation is for a new record. Whenever I'm updating it or saving a new record. So it's giving me my error message. Hire date should be greater than today. Because it compared this date, whatever I entered here, with the ADF.current date, that is this date. And the validation failed. And it's not letting me move from this attribute to next attribute. That is because I have validation at attribute level. Okay. If I had it at entity level, I could have freely moved across the attributes, but only when I say next record, then the validation would have failed. So that's the level where I'm putting my attribute. Okay, so that explains our attribute level and entity level validations. And we got one validation here. Okay. Similarly, go to validations. Okay, yeah, so that's how we define validations here. And I used compare type of validator here. Let me use some other type, especially the method attribute, method validator. I'll delete this here. I'll create a method validator on salary. Okay, I'll go here and I'll say method validation, and it's giving me a method. And if it fails, I'd give a text that salary should be, I'm going to validate it for greater than 100, should be greater than 100. I put a message and I'm going to create this method. I say, okay, go to my Java class and EOIMPL, there will be a validator. Okay, this is a method it created and it's by default returning a true. It means it's passed. But I want to put my condition here. So I would say, if this dot, okay, I said accesses, right? I'm going to get my salary. So for that purpose, I need to say get salary to get the value in salary. Oh, no, actually not get salary because we have not yet set the value. The salary is incoming from here in the validator. So what I'll do is I'll check this salary. If the salary is less than 100, just return false, else return true. One second. Actually, because it's a big decimal, I need to compare with only a big decimal. So I'll say new big decimal. Here. Had it been int, it would have been easier. Let me do one thing. Let me come to a simpler data type. Otherwise, we need to use functions and it will confuse you. I'll change the data type to integer. I just want to show a simple example. That's why I'm reducing the data type. Okay, that's fine. So I'm taking input value as integer and comparing it with 100. So if it is less than 100, throw an error. Let's go and test it. I open the employees view and I change the salary to something less than 100. I got the validation message immediately. So this happened programmatically. We used a method validator. Okay, we used a method validator here, method type of validator, and it's invoking a method in my IMPL class, which is giving me true or false. Based on that, my validation conditions will execute, whether I should show any message or go ahead. So that's how you define basic validations. This can get very, very complex by using a lot of tokens and expressions. Just wanted to show you the basic flavor of how you can put the validations. Okay. That's pretty much about attributes and validations. Next we'll move on to associations. Okay, what are associations? Associations are basically joins between two entity objects. Okay, let's create one association and talk on that. So we'll see what types of associations are there and specifically focus on composition type of association. And then we'll choose that options in association. So this is a small topic. I'll create one new association. That's a join on two entity objects. I'll call it DEPT EMP association. And here I'll define what's the join between the entity objects. For example, I want to take this department EO, and in that I have a department ID. I want to create association between departments and employees based on the department ID column. What it means is I selected these columns and I say add. Essentially, I'm creating a join condition between these two entity objects. What I'm doing is I'm linking these two EOs based on department ID. So an association gets created. Accessors and all we'll revisit later when we come into programming thing, but just definition of association we'll see. I got an association created. On top of that association, I want to test it. So corresponding view link should be there. We have two entity objects, employees and departments, and on top of that we have two view objects, employees and departments, and I need to create a view link between them also based on this association. Otherwise, this association is of no use because I want to test this association in app module tester. So for that, I need to have view objects. So let me create a simple view link also. This map one-to-one, view links and association map to one-to-one. So I'll call it the same way, DEPT EMP link. I say next. And here, because we have the association already defined, what we can do is we can expand that and use our I said DEPT, I misspelled it. So this is the association which I created. And just using that, I am creating view object. Don't bother about other things. Finish it. Now, using this link, I can create a data model here. Let me clean it up again. So with an empty app module, I'll first take the departments view on the top level. And inside that, I want the employees. It means I want to see employees for each department individually. I'll scan through employees view object, and it will join to the employees view object and show me one by one. So let me run this app module. Okay, I got the M tester. If you see, the structure is still there. I have a departments view on the top level, joined by a view link to the employees. If I click on this departments, I'll see only departments. But if I click on this view link, I'll see the master detail relationship between these two tables. Okay. So for department ID 60, see the last column. Bring it here. For department ID 60, I have this many employees. And I'm traversing to next department. 70, I have one employee. And in 80, I have these many employees. So essentially, we made a join between these two tables, which is called an association. And based on top of that, we built a view link, which we are using to display the data on the user interface. Okay, so I just want you to know that there is a way to do that linking here. Don't worry about the details. When we go into the master detail display on the UIs, you'll appreciate this concept better. Okay, I just want to show you that association. Let's open this. So in joins, we have different types of joins, right? One to many to many, one to one, etc. That's called a cardinality. Here also, when we define the association, we can define the cardinality. When I was creating it, I left it as the default, that is one to many, because one department will have many employees. I used it one to star. The same thing is showing up here, cardinality. Okay, and forget about accesses for now. Let's see the behavior part. So there are some options here. This will define the behavior of entity objects when we commit them. So use database constraints will be used when we are modeling the database in JDeveloper and putting that into database. So we are talking in the beginning of the session, but we can create a database model in JDev itself and push that created artifacts into the database to create tables. So in that case, if we have association, we can say create this join in the database also. So this option is for that. An interesting option is the composition association. What composition association means is when two entity objects are related by a composition association. What it means is, suppose there is an invoice. Invoice will have a header and some lines of data of which products you have bought. The header will contain the amount, the date on which you made the transaction, your name, etc., which is the header. And then it will contain some lines of data. Like you bought some 10 products, so you have the 10 lines of describing the products. Here, header can be modeled as one class, lines can be modeled as one class. And they are associated that one header will contain multiple lines. But the peculiarity about that association is there is no meaning for lines without the header. This is called a composition association. It means when one entity cannot exist without other entity, we can call it composition. Like the main entity is composed of child entities. So child entities don't have any significance when there is no main entity. If there is no header at all, there's no sense for the lines. Where do they belong to? They are just orphans. So that kind of relationship becomes important for us because when we mark an association as composition, we have to take care of all these options. What? Like suppose in the invoice example, if I delete the invoice row, Obviously, there is no sense for keeping line rows. I should delete them also. So a cascading delete has to be implemented. Who will take care of that? Obviously our ADF, because it's writing the queries for us. So we should let us know that this is that type of association. If you see the option here, implement the cascade delete. So if you select this, if you define this association as a composition and select that it's a cascade type of delete is required, then ADF will take care of doing that. For example, in our current JDEV example, we are creating composition association between departments and employees. So what happens is, if I delete this department, all the employees get deleted. So we are telling JDEV, ADF framework, to implement such cascade delete. Okay, this behavior. Like that. Okay, we have some other options. We'll see them later. This will be overhead to you. I just wanted to expose that there is a type of association like this. Okay. And we'll come to the last topic, that is the life cycle of entity object. So what happens when you create an entity object or update an entity object and commit that? So basically two operations you will take on entity object. That is a creation, you are creating new rows of entity object, or second thing, you are updating existing objects. And finally, whatever you do, you'll commit that to the database. So how the commit flow goes in. Okay. More than the textual thing, let's say the graphical thing, you'll understand it better. So entity object will have some states. Associated with each object, there will be some states. Based on the states, framework will decide what to do with that entity object. Okay. First, let's go with the find flow, which is in the bottom. Okay. What is find flow means? We are reading entity objects from the database. Suppose now I do a select star from employees. I got my 10 rows. All these rows will be in the status unmodified. Each row will be of the status unmodified. So what it means to framework is, there's nothing that happened on this object. It's simply queried from the database and it's in the cache. There's no action required on this thing. So framework just sees the status and okay, let's it be there. Now, when I change any attribute on that row, I queried that, right? I updated the first name of an employee. Then essentially we are doing a set attribute call on that attribute. So whenever any of the attribute changes, the entity becomes dirty. It means it has to be persisted back. So then it transitions the state to modified. That particular row which we modified, which we did a set attribute, will transition to modified state. Okay. So when it goes to modified state, framework knows that this row has to be saved. So in this picture, I have depicted all the states in that rounded rectangles, and which are shaded with a square rectangle are those which are of interest to ADF framework. They need some action from the framework. Okay. So this modified one will need an action. What is that action? It has to be either committed to the database or removed from the cache. Maybe I want to delete that row, or maybe I want to save that row. Suppose if I committed that row, what it does is, for this row, it will write an update query and update the database, and again change the status back to unmodified, and it doesn't bother about the row. All this thing we are talking in the context of one single row. Same thing applies for all the rows. Okay. So suppose 2 rows are modified, those 2 will be set individually to modified state. Suppose after modification, or even without modification, if I call a remove, that is, if I delete that row, it gets into deleted state. Even then, framework is interested in it because it has to do a delete DML onto the database. So when I delete it, what it has to do is, on the DB, it will execute the delete command. and move the status as dead. It means it doesn't even show it to me, the user. In the commit case, we had it in the unmodified state that we are able to use it still. Just use it. The framework is not interested in it, but we can see it. In this deleted case, it goes into dead state, which means the row is no longer available. Okay, this happens in the find flow. Similarly, in the create flow, if you come here, in create flow, we don't read the database first. We call a create row method. In fact, we call it a create instance method, where one entity object row is initialized. In the initialized state, there's nothing ADF framework has to do about it. It will only create a memory allocation and create an entity object. It knows the definition, right? So it creates an instance of entity object, just that much. Then, if suppose you have a default setting or you have modified some value, again some set attribute gets called. If any of the data has been set on the initialized object, it moves to new status. When it moves to new status, again framework is interested on that, because if it is a new record, we have to execute a create command on the database. So framework will be interested. Once it does that commit and does the create execution, again it moves the status into unmodified state. So now in the this is all happening in the cache. Similarly, when you remove the new record, you created the new record but don't want to commit, you can delete it. Then also it goes into dead state. So this life cycle and the state transitions will explain you what is happening in the background. So this picture is very important for you. That boxes, the red box, like in the square boxes which I have used, is where the DML operations will happen. When you goes into this state, framework will create the DML statements. For example, in the modified case, it will create an update statement. In the deleted case, it will create a delete statement. In the new case, it will create a create statement in the background. You don't see it. In the background, it creates and executes on the database. Okay. So that concludes our entity object inspection. Any doubts still here?
No, sir.
It's fine, right?
Yeah.
Let's end this session and we'll do one thing. I just want to give you a startup with JDeveloper. So I wish to see your installation and see that you're able to create the projects and test the stuff. Otherwise, if you get stuck here, again, you'll not have a chance to go ahead. So I would like to see your your environment. You can share your screen. Okay, I'll give you presenter role. I'll stop the session here and we'll see your environment.